Hello, my friends, and welcome to this new practical activity, which will be, an exciting one because after implementing the UCB algorithm, we're about to implement a new one, and we will see if this new one, which is Thompson sampling, will beat the UCB. So I just want to say here that it's important that you check out first the UCB section, and the practical activity before doing this one, because we will work on the same data set, and I will mention several times the UCB so that we can compare the two performances. All right, so make sure to check out first the section on upper confidence bound, and if that's the case, you're ready to go. Okay, and then let's make sure everyone here is on the same page. I gave you the link to this folder, Machine Learning A to Z Codes and Datasets, right before this tutorial in the article, so make sure to connect to it. And now, all good, we can start. So let's do this. I can't wait to not only implement that new model, Thompson sampling, but also to see if we're going to beat the UCB, meaning if we're going to manage to catch that best ad in 500 rounds or less, okay? So once again, I gave you the slide of the whole Thompson sampling algorithm. So I really recommend that you open it. You have the 3 steps, which we will implement together in the following tutorials. And once again, you will implement the steps on your own before we do it together, because that's the best way to practice and progress in machine learning. So that's the slide. And now we're going to go into the Python folder, in which you're going to find 2 files, that exact same data set of the 10,000 rounds, or the 10,000 users in the rows, and then the 10 ads in the columns. And so I remind that successively we're going to show ads to each of these users, and because this data set is a simulation, we know for each of them on which ad they're going to click. So for example, this user is going to click only on this ad number 8. All right? So that's the same data set, and now here is the implementation, Thompson sampling, in the IPYNB format. So if you're ready, let's open it in either Google Collaboratory or Jupyter Notebook, and I will show you what we're going to do with it. We won't have actually to re-implement it from scratch, because it is actually very similar to the UCB implementation in the sense that we have the same data preprocessing, the same beginning of implementation when implementing the model in the cell, and the same code with the histogram in the end. So we will actually only re-implement a part of this cell, where we have indeed to implement the 3 steps of Thompson sampling. Okay, so, but first of all, as usual, this notebook is in read-only mode. That's because you all have access to it. We can't modify it, of course. Therefore, we're going to create a copy here by clicking File and then Save a Copy in Drive. And this will create a copy, and that's where we will re-implement part of this implementation, where we have something different than before with UCB. All right, so, speaking of this, let's see where we have that difference. Okay, so first of all, you see that we have the exact same structure as before. We first import the libraries, then we import the dataset, then we implement the Thompson sampling algorithm, and finally we visualize the results in the histogram. I'm not going to click on it because we will keep the surprise for the end, but there you go. That's the exact same structure. Now, not only this is the exact same structure, but here, this is the same code. Here as well, this is the same code. We import the dataset the exact same way. And here, here we import a different library, which is the random library, and that's because, we'll have to work with beta distributions. When we take a random draw from the beta distributions, we do this with this random library instead of the math library in the UCB implementations, which, by the way, I've kept here because, at the end we will compare the 2 results of Thompson sampling and UCB. So there you go. We import this library. Then we have the exact same parameters here. That's the total number of rounds, or, the total number of users to whom we show successively the ads. Then this is the number of ads. We have 10 ads, among which we want to find the best one, the one with the highest conversion rate. And about that, I insist to remind that there is this important assumption in the dataset that each ad has a fixed conversion rate. And the goal of our implementation, the goal of what we're doing here, reinforcement learning with online learning, the goal is to find that ad having the highest conversion rate. All right. So far, exactly the same, just that library changes. We're using a different library. Then here's the same. We make this variable to prepare, the list of all the ads that will be selected over the rounds, and we initialize that list as an empty list. So exactly the same. Now, this is where things change. So actually, we will delete everything from here. We will delete all this cell, all the part of the cell from here and we will re-implement all this because all the rest is the same. And same for this histogram, this is the exact same code as in the UCB. Basically, everything here is the exact same code as in the UCB, except for this line where we import a different library, and only what we're about to implement right now is specific to Thompson sampling. So that's why I told you to really study first the practical activity of UCB if you did not do it already, because indeed we're going to start from here instead of re-implementing everything we already did. So there you go, my friends. Now we're ready to start. So join me in the next tutorial to implement Thompson sampling, and then in another tutorial after that we will of course visualize the final result and compare them with UCB. I can't wait to start. See you in the next tutorial, and until then, enjoy machine learning.